Okay, we'll perhaps make a start. I assume the sound is coming through okay, and please note we're recording the session. So welcome to this afternoon's virtual tutorial. My name is Kevin Stratford. I'm with the support team at EPSRC for the Cirrus service. While this is called a virtual tutorial, I'm not really sure that's the correct name. This is really going to be something which is nothing more than a précis or a gloss of the existing online documentation for Cirrus. And perhaps we'll give you a chance to ask some questions if you'd like. If you want to ask a question during the presentation, perhaps the easiest way to do so is to type it into the chat, and we should pick that up. Okay, so the Cirrus service, many of you will know, has actually been in existence for about 4 years. There was recently a hiatus for various reasons, including a security incident back in May, and the time table so panned out that it was expedient to make an upgrade to the machine, which had been on the cards for some time. So this presentation will discuss largely the existing setup and things that have changed. So it should be interesting for people who have used it in the past and perhaps also using it for the first time. Okay, so here's the outline. I'll say a little bit about access mechanisms, how you apply for time for those who might be interested in such things. The bulk of the talk, as I say, will basically be a gloss of the existing Cirrus documentation. The true and correct form of this documentation is at the website for the Cirrus documentation, the URL of which will appear at the end of this talk. These slides should not be considered a reference in my view. So we'll deal with all those things one would like to do as a user, and if you have any questions I can perhaps attempt to answer them. Perhaps just at the end we'll go on to have a look at what new hardware appeared during the upgrade and how one can go about using that. So just to put the whole thing in context, in the UK we have this idea of a hierarchy of services, the top of which, so-called Tier 1, is the national service, which is ARCHER, and this is there to fulfill the requirement for the largest parallel jobs of a capability nature. There's then a second tier, of which Cirrus is one element. Other services are available, as the advertising people say, and these fulfill the need for intermediate level of computational resource or specialist requirements. So for example, some of the tier systems are limited to certain topics, for example materials chemistry. Others, such as Cirrus, are general. There is also a third tier, which is broadly institutional level facilities, which many of you will have either within your university or institute. So there's just a little here on mechanisms for access. One can apply for time on Cirrus as part of the standard EPSRC research grant proposal in responsive mode, and CPU time can be requested as part of that process. There is also something which EPSRC have labeled access to high performance computing, which some of you may recognize as something which used to be referred to as the Resource Allocation Panel, or RAP, which is a twice yearly call for basically what is extra allocations of CPU time. The next close for that call is actually on the 4th of September. So there are another methods of access which are specific to Cirrus. We have instant access. The idea here is a very low overhead application method which we can turn around in a few days, and this might be used, for example, to, if you want a small amount of time to run some benchmarks to go in to a larger proposal. That's one way to get that. We also have a number of commercial users on the system, and they have their own agreements. If you do wish to apply for time on the system, one of the things you will be asked for is something which we refer to as a technical assessment. The deadline for this document, it will be some 4 weeks before the final deadline. So for the 4th of September deadline for access to HPC, the deadline for technical assessment is 7th of August. So the basic name of the game here is we wish to check that the proposal is technically possible. That is what you're asking to do, can be done on the machine, legally possible. That is, do you have the correct licenses in place to be able to run what you wish to run? And all these things are reasonable for Cirrus. I mean, as part of that process, we might, if you're asking for a great deal of time, we might try to encourage you to go up a scale to the tier 1, or make other suggestions. So the requested resources, which boil down to core hours for Cirrus, in the technical assessment, we will be seeking to make sure these make sense, and are they necessary and sufficient to answer the scientific question at hand. This is often something that's a little difficult to get at, but what we're looking for here is a statement that broadly addresses the question. To answer such and such a question, we need to run such and such a code on so many cores for so much time, and we need to do this for a number of repeats, and that will give us a total number of core hours which is required for the work. Okay, I'll perhaps just pause there and wonder if there are any questions on the issue of how to get access. See, Claire has put in the URL for access in the chat window. Okay, if not, we'll keep going. So as I wait on, there is there, so Andy asks, is there a typical size for Cirrus applications in core hours? That's I don't have a figure in my head really for this, but one of the things we would be looking for, if you think the existing CPU resource has about 10,000 cores for a year, if you want to use 1% of that, that's probably good. If you're asking to using 10% of that, whatever that translates to in core hours, we probably start our antennae would be starting to twitch that you were asking for quite a lot. Another question, are there still special access mechanisms for Scottish researchers? My understanding is that mechanism is still in place, and details are at the at that URL, which is posted in the chat. Okay, so existing, the existing, what I'm calling the Phase I incarnation of Cirrus first appeared in late 2016. It's based on a HPE cluster, and it had some 282 Intel Xeon nodes. 2 nodes are used as login nodes, leaving 280 for compute nodes, which appear in the queue system. Each of those nodes had 2 sockets, each with 18 cores, and the whole node had 256 gigabytes of memory. The whole thing was connected by an InfiniBand FDR network. The FDR bit is, I think, stands for 14 data rate. The rather mysterious figure of 14 translates to about 56 gigabits a second bandwidth. There's a standard Lustre parallel file system with about 400 terabytes of space on it. This piece, which is I'm going to refer to as Phase II, retains all the older components. So those 282 in inverted commas standard nodes are still available. We also have 2 what I'm going to refer to as older NVIDIA V100 nodes, and we've also as part of the break we had in the service about a month ago, we upgraded the operating system to take care of a number of concerns, including some security concerns. Those of you who are using the system before will have noticed some of the software which was available before has been, in inverted commas, removed, so that we can try and keep things up to date. So I'm sure all of you have enjoyed logging in with SSH public-private key pairs in the new regime. So just a quick look at this. So the idea is to generate an SSH public-private key pair. Those exist. This is my MacBook. So I have a directory .ssh in my home directory, in which I have an SSH public and private key pair, exactly those permissions, and so you upload the public piece to the safe and you should be on your way. Please, you should not, if you find yourself copying the private key around, I suspect you are doing something wrong. So the private key is private and should remain so. So when you log in, it's now a two authentication step security with your SSH passphrase followed by machine password. There are various mechanisms to try and make this a little bit easier. Here's the one I use. So in that .ssh directory on my machine, there is a file which is called config, which has configuration details for various machines. The section for Cirrus in my SSH config looks like the following. There is this host entry which specifies which host I'm looking at, and in this case it's Cirrus, and various names by which I can refer to that. There is this identity file section which lets SSH locate the relevant private key in this case, which has a non-standard file name. This control master stuff, some of you might be interested to have a look at this. This allows you to basically, when you first authenticate, you can cause SSH to create a socket which further SSH connections can then piggyback off, and that means you only have to authenticate once per day typically, which I regard as a reasonable balance between inconvenience and security. If you're interested in X11 X applications, you may also want to have X11 forwarding. So the sort of user environment, it's fairly standard stuff. It's Red Hat Enterprise Linux 8.1. When you land in your home directory, you should see that your home directory is something /luster/home. Then there'll be a project followed by a user ID. So for example, I'm in project Z04. My username is Kevin, and so that's my home directory there. You can query the Lustre file system to get at things like the quota. So for example, the group quota, this -HG option for Z04 shows the group as a whole. So some information on the current state of the system is available via that mechanism. For information on actual budget in core hours, you currently have to look in the safe to get hold of those details. So a question, just going back to the last slide, what this control persist thing in this SSH section determines how long that socket will remain in terms of seconds. So 10 minutes is allowed for that socket to remain in existence if there are problems with the connection. Okay, so if you want to move data and code about, these are standard mechanisms, can be used to do those things. So for example, if I want to move things onto the machine, it's usually scopy. If I want to keep copies of important material such as source code, it goes into a repository in an external service. Some people like to use rsync. I don't, but that's also available. Just one note on the default file permissions on Cirrus. If you create a file, a new file, it will appear with the permissions as seen there. So that's user has read write, group has read, and world has read permission on that file. That's not actually the end of the world, because your home directory will probably not have world readable access, so the whole world will probably not be able to see that file residing in your home space. At the group level, however, you may wish to consider changing the default UMask. Okay, I just have another quick pause there to see if there are any questions on that stuff. Maybe a bit of a delay in these questions, and that may be why I'm appearing to be going backwards and forwards slightly. Okay, let's keep going. So in terms of what software is available on the system, this is a standard module system. So if you do module avail, you'll get a big list of all the available modules, which I've edited somewhat here to make presentable. So, for example, this Altair stuff is a sort of multi-physics package for which you must have a license. There's things like Intel compilers. There's also open source software. So GDAL is geospatial data manipulation, and OpenFOAM is a CFD classic. If you want to narrow down your options a little bit, you can do module avail, in this case GCC, and that will show you that there are 3 versions of this available, of which GCC 6.3.0 is the default. So to use these, so we give you a couple of modules are loaded when you first log in, to give you a couple of standard things like editors and revision control and so forth. So that's should be already there when you log in. If you want to load a module, it's module load. In this case, I've tried GCC, and because I've not specified the version, I get the default version. Unload does the opposite. Now, this is all fairly standard stuff. Perhaps more interest, and more particularly because we've changed since the previous incarnation of the service from PBS to Slurm, is the queue system. So the new queue system, Slurm, has a number of concepts, perhaps you might call them, which are useful to think about. It has the idea of partitions, which are broadly what is the physical hardware involved. So the command sinfo here will give us the information on what partitions are available. Again, I've edited this slightly to be more presentable, but you'll see there are basically 3 partitions on the system. This one, which is standard, which is the Broadwell CPU nodes, and if you tot up the number, it should come to 280. There are 2 GPU Skylake nodes, which are the older GPU nodes, and the new what we've called GPU Cascade, which are I thought there were 36, but it's saying 34 here, new nodes there. So Slurm also has this idea of quality of service. So when you submit a job, it will end up in a physical partition, but in also to determine the limits in terms of resources, there's this idea of quality of service. So this rather strange command gives us an overview of quality of service. So there is a standard quality of service which goes along with the standard partition. You'll see it has a maximum wall time of 4 days here, or 96 hours, and there are certain number of maximum running jobs per user, which is 20, and a maximum number of submitted jobs per user, which is 500. There are a long quality of service, which has a maximum wall time of 14 days, and also of interest is the GPU quality of service, which must be used for the GPU queue. The maximum size of job you can run in the GPU queue at the moment is to use 16 V100 cards, which is 4 nodes. So if you want to know what is currently in the queue, you can type SQ is the appropriate command. There's a slightly cartoon example here in this slide. You can see there are 2 jobs from user 1 at the top of the list. One in the central column, which is ST, is the header of the column for state, is showing R, which means it's running. And because this particular user actually has 19 other running jobs, he has one that is also pending, PD. Slurm is sufficiently polite that for the pending job it tries to give you some idea of why the job is pending, and this is because this user has reached the 20 job limits, which is the quality of service for the standard queue. You'll also know in the center there are 2 jobs with job ID _0 and _1. Those are 2 elements of an array job, each of which appears to be using a separate node. So I'm expecting that to be an array job, each element of which is some parallel job using 1 node. And there's, at the bottom there's also what looks like a parallel job which is running 4 nodes. If you want to restrict the output to yourself, you can use this SQ-U and then your user ID to restrict the output. Okay, so how do we go about submitting a job? This is sbatch is the appropriate command in Slurm. Sbatch has quite a lot of options. Typing them out on the command line can become rather unwieldy, so it's usually appropriate to put these commands in a script and submit the script. Successful submission, Slurm will return you a job ID, which is a number by which you can identify the job. And if you realize you've messed up, you can delete the job with the command scancel and the job ID. So I've got a few examples here of some submission scripts. For the purposes of presentation, these are rather cartoon examples. To get true examples, you should really look at the documentation in full. So the submission script is just typically a bash script. So we have the shebang at the top, /bin/bash. As this is a bash script, comments are usually introduced with a hash sign. So we have these special comments which announces options for Slurm to recognize. So here are a number of examples of options which are needed. This is about the minimal example I think will run on the system. So in order to submit a job, we need to tell Slurm what resources we're going to need. So I've asked for one node, minus nodes equals 1. I must specify a time limit, a wall clock time limit, with minus time equals here 0 hours 10 minutes 0 seconds, and I must specify an account which for me is this account Z04. For you it will be different. I must also specify a partition, which in this case is standard, and I must specify a quality of service, which is also here standard. So those are examples of the options which are available for batch submission. They are by no means exhaustive. Very large number of possible options for batch submission. That's about the minimum one you can get away with. In the previous example, I've asked for one whole node, which is 36 cores. If I don't want to do that, if I just want a serial job, what you need is something like this sbatch minus n tasks equals 1, and that will give you, that will allocate you one core rather than a whole node. So that is a mechanism via which nodes may be shared. So here's an example for a parallel job. So if I know I want to run a job which is going to take up 4 nodes, and I want 36 MPI tasks per node, and I know that I'm going to run basically no threads in this picture. So there's an incantation here, CPUs per task equals 1, which is saying I'm basically going to have 1 thread per task. And here I've specified minus exclusive, which means I'm going to get whole nodes. And so my MPI job will not interfere with any other work, hopefully, and no other work will interfere with my job because I'm going to occupy the entirety of 4 nodes. So to launch an MPI job, one uses this thing srun, and then your executable. So srun will pick up the fact that I have 4 nodes and 36 tasks per node, and realize that I want 144 MPI tasks in total, and all that will happen through Slurm. So here's an example of an array job. You specify the number of elements in your array via this minus array, so 1 to 100 here. So 1 being the first and 100 being the last. And you can, basically your script should then perform action which is dependent upon the value of this environment variable Slurm array task ID. And you can do whatever you need with that. So the important thing to remember about array jobs is that the resource requirement you request is a request per element of the array. So each of the 100 instances of this thing, in this case, will ask for 1 task, i.e. 1 core only. A few folks like to run interactive jobs. The best way probably to get at this is to do something like the following. Here you do need to specify options to, in this case, srun on the command line. So here I've got srun exclusive nodes equals 1. So this is going to give me exclusive use to 1 node. I need to specify a time limit, an account, a partition, and a quality of service, which is represented by the ... here. And I also specify this pty /usr/bin/bash. So this is the bit which is telling me I want an interactive job. Depending on availability, that will start in a few seconds, or if there's no nodes available, that may not start for some time. When it does start, you will appear to be logged in to the relevant node, and then you can use that interactively as you would normally. When you've finished, you can type exit or hit Control-D and you'll return to the front end. This is, if you do have significant work you wish to run in an interactive fashion, this is the preferred method. Please don't overload the front end, or you will attract the attention of the authorities, as they say. Okay, so that's, as I say, a fairly cartoonish gloss of what is described in more complete detail in the online documentation. So the last section is just to say a little on the expansion of the existing service to include some new GPU facilities and some fast non-volatile storage capability. The aims of which were one, to support AI and machine learning more fully, and perhaps more interestingly, to be able to explore a larger heterogeneous architecture with a view to what will be coming in the future in terms of exascale machines. So what we have is 36 new Intel Xeon based host nodes, which each have two sockets of 20 cores and 384 gigabytes of memory, and each node has 4 NVIDIA V100 cards, each of which has 16 gigabytes device global memory. So if you're in the game of doing things like compiling GPU applications, then there are relevant modules available. They all tend to start with NVIDIA something. So for example, if you're interested in OpenACC, you'll be wanting NVIDIA compilers module and so forth. And I assume, I haven't actually seen what's in the math libs, but I assume it's the cuBLAS and cuFFT and all that stuff. So if you can compile your application, you can then think about submitting a job. This all looks much the same as it was before, except for the 3 things seen in this slide. The partition must be now GPU cascade, to separate it from the older GPU Skylake nodes. The QoS is also equal to GPU here, and there's this extra GRES option, or generic resource option, which is saying GPU:4, which is asking for, I want all 4 GPUs on this node. So it would make sense here for this to be an exclusive node job. If you don't want all 4, you can specify, for example, 1, and then your CUDA visible devices will only have 1 GPU card in it. So that's the kind of thing you'll be wanting to look at to run a GPU job. Another way, a lot of people I know doing machine learning type stuff, where the software stacks are rather complicated, do things like use containers. So this point is worth mentioning that Singularity is available in Cirrus, and you can run containerized software by loading the Singularity module, and then Singularity run with your Singularity image file in the normal way. There are a couple of other additions associated with the new part of Cirrus, the details of which are still coming into being. So there is some capability to add about 256 gigabytes of non-volatile storage. This will appear as a file as a file system, the exact deployment of this fast storage, I think we've yet to finalize, but it's possible it may be deployed as a sort of scratch disk space for use at runtime, where you may perhaps want to stage data or keep frequently used data set in this layer of fast storage. Details will become available as they appear. The GPU nodes have a slightly faster InfiniBand, this EDR InfiniBand Swiss, which gives a slightly better bandwidth than the older network. Again, we should be coming forward with exact details on those as we get a bit more experience with using them. Okay, just a couple of final points. Please remember to acknowledge Cirrus and EPSRC in your work. There's a form of words available in the introductory section of the online documentation, which is, as I say, the true and correct reference material, which can be found in that location there, cirrusreadthedocs.io. If you want information on access, go to the cirrus.ac.uk access page, or have a look at the current EPSRC calls for details on the access to high performance computing call. As ever, if you have any issues, please contact service desk at that email address. So perhaps I'll make a finish there and leave that up and see if there are any questions. It's perhaps worth saying that some of these, we're still slightly exploring some of these new Slurm options. So things like the quality of service may be evolving in the near future to allow different types of jobs. And if you have any requests on that front, please let us know. Likewise, any requests for software that you need that does not appear to be present, you can ask the service desk and we'll see what we can do. There's a question here, could I please say something more about the new GPU nodes? I'm not quite sure in what context that question is coming from. Capacity in terms of as I said, the device global memory is 16 gigabytes on these GPU cards. That's usually the main thing one worries about. One thing I'm not sure about is I'm not sure they support CUDA 11. We're not offering CUDA 11 just yet. We're still on CUDA 10. So that's one thing to be noted for those GPUs. Well, 16 gigabytes, there's the comment in the chat says that 16 gigabytes is not a lot, but it's perfectly standard for GPU global memory, I would say. The host memory is much bigger, but that's a slightly different question. Okay, perhaps if there are no more questions, I'll say thank you to everybody for attending. I hope that was of at least a little modest interest, and say goodbye.